At which x values does this function have removable discontinuity? Removable discontinuity is a point in the graph where the limit exists, but it's not discontinuous. So the graph has a hole or a break, but the limit exists. Now that happens at holes. Limits exist if the left side and the right-sided limits are the same number, which means the limit exists at that spot. If we're looking right here, we have a hole. Even though there's a value up here somewhere, this guy has a left-sided limit that matches the right-sided limit, and since those guys go to the same thing, the limit exists here at 1. So x equals 1 is an option. Also, we have a number here at 3. Now, there appears to be a hole here at 3. There's a right-sided limit that goes to 0. However, there's no left-sided limit, which means right here, the limit does not exist. Looking at 5, you have a hole. And as you go to that hole from the left and go to that hole from the right, they approach the same number, and that number happens to be 2. So since these guys have a left-sided and a right-sided limit that are the same, it's going to also have removable discontinuity. So your removable discontinuity exists at two places where x is 1 and where x is 5. Given the following limit function, for which value of c does the limit exist? Well, we have a c here, and we're asking where the limit exists when x equals 5. So this is what we need to understand. If a limit is going to exist, that means the left side and the right side of a limit have to meet at the same spot. And when we think of stuff like this, we think about holes. Now, holes exist if you were to factor out an equation and factor out another equation, and some factor up here is the same as some factor down here. So what we need to do is we need to come up with the fact that this guy, which is x minus 5, has to have an x minus 5 living up here somewhere. Now, if this is x minus 5, and that's a factor, I have to come up with another factor, whereas negative 5 and some number have to add up to negative 2. Now, negative 5 and positive 3 would add up to negative 2 if I were to FOIL this out. So, if I were to FOIL this out, if I multiply negative 5 to positive 3, that would make c negative 15. So in order for this to have a limit that exists, c would have to be negative 15, because then I can factor this out to x minus 5 and x plus 3, and x minus 5 would exist on the bottom, therefore giving me a hole. So c in this case has to be negative 15. A strange problem. Given the function f of x equals x squared minus x minus 12 all over x squared minus 6x plus 8, at which x values is there a discontinuity due to a vertical asymptote? So let's think back about AP pre-calculus, those of you who took it. We care about when there are vertical asymptotes if we factor something and there's something on the bottom that's nothing like anything on the top. So what I have to do is factor both of these quadratics, and let's see where I have a vertical asymptote. Two numbers that add up to negative 1 but multiply out to negative 12 are going to be x minus 4 and x plus 3. Two numbers that add up to negative 6 and multiply out to positive 8 are going to be x minus 4 and x minus 2. Now, we have a repeating factor in the numerator and the denominator. That's going to be your whole. I don't care about that. We have a factor up here that's nothing like anything in the denominator. That's going to be a 0. We don't care about that. But what we have here is a factor on the bottom. And when I have a factor on the bottom, whatever that factor equals 0, or whatever x value that makes that factor 0, which would be 2 in this case, is going to be my vertical asymptote. So I only have one vertical asymptote, and that lives at x equals 2. So that's going to be my only option. X equals 2 is my vertical asymptote. That is going to be where my discontinuity exists. Consider the function f of x equals x squared minus 4 over x minus 2. Which of the following statements is true regarding the discontinuity of this function? Well, let's find the discontinuity of this function. It looks like I could have either a vertical asymptote or a hole depending on what the upstairs factors to. The numerator is a difference of squares, so let's factor that. X minus 2, x plus 2, all over x minus 2. Now, since I have a factor of x minus 2 and x minus 2, one in the numerator and one in the denominator, that's going to be a hole, and that hole exists when x equals 2 because that's the number that would make this undefined. So at x equals 2, I have a hole. So let's see what our options are. Which one of these is true? There is no discontinuity. Well, that's not true because there's a hole at x equals 2. There is a removable discontinuity at x equals 2. Now, what removable discontinuity means is you have discontinuity where the limit does exist. If you have a hole, the left side and the right side of the limit exists because they are the same, which means the limit does exist. So a hole represents removable discontinuity. So B is going to be my answer. So no, not jump discontinuity, no, not infinite discontinuity, whatever that means. Maybe that's a vertical asymptote. In this case, since it's a hole, we have what's called removable discontinuity because the limit does exist.